This problem involves an array traversal algorithm. We're asked to write a method called numUnique that takes a sorted array of integers as a parameter and that returns the number of unique values in the array. So for example, with this array here, there are a bunch of different values, but a lot of duplicates. So in fact, there are only 5 unique values in this list here, only 3 unique values in this list here. This is a list that has more unique values in it, but still some duplicates, 8 different values total. This is one where there are 12 values, all of which are unique. And we could have an array that has just one thing in it. We could have an array that has one value repeated many times. So the answer in both of those cases is 1. We could have an empty array. There are no unique values in an empty array. So these are all cases that we're going to have to consider in writing our solution. I've set up a JGrasp file that has each of these different arrays as a testing case, and a short little testing program here that just reports the contents of the array, shows us the length of the array, and then calls the numUnique method to report what value it's returning. And notice that in order to get the text version of the array, I'm calling the arrays.toString method. The built-in toString method for an array does not provide a very useful result. So this is a case where arrays.toString is very helpful. So we're supposed to write a public static method called numUnique. It's supposed to return how many unique values there are. So its return type is going to be an int. It's called numUnique, and it's passed an array, integer array, that we could call list. So we have to figure out how to fill in the details of this numUnique method. There are a lot of ways to approach this problem. One way to approach it, for example, would be to have a two-loop solution, kind of an outer loop that would be going through each different value, the 1, the 2, the 3, the 4, the 5, and then an inner loop that would scan past all the 5s, or scan past all the 4s, or scan past all the 3s. So that would be an approach to take. Turns out that's kind of tricky, so we want to try to figure out a simpler approach if we can. And as the name implies, array traversal, this is something that can be solved with a standard array traversal or a slight variation. So the standard array traversal is to start with an integer variable I that we initialize to 0, I less than list.length, I plus. So a lot of array code that we write ends up looking like this, or if not exactly this, some slight variation on this. And what we'd like to do is to figure out some way to count as we go. So we'd have an integer counter that we could start at 0, and then as we traverse through this list, what we'd like to say is if something has happened, we've got to figure out what that something is, then we'd like to increment our counter. So count plus, and that way when we're done with our loop, we'd be able to return that count as our answer. So this is the approach we'd like to take, is to do a scan through the list, a traversal through the list, and as we do that, somehow to count. Let's do that by hand first and just kind of explore what that would mean. So let's go through this array right here and try to figure out what the count should be. So when we've seen this first value in the list, obviously our count would be 1. We've seen one value. When we get here, our count would go to 2 because now we've seen 2 different values. When we get to here, our count would stay at 2. We've seen another number, but it's not a different number. So the count of unique would still be 2. Here the count would still be 2. Here the count would go to 3. And then when we move to here, count would go to 4. It would stay at 4 here, go to 5 here, go to 6 here, stay at 6 here, go to 7 here, stay at 7 here, stay at 7 here, go to 8 here, and then we'd report the 8 right here. So we want to think about those points where we were changing our count. So why did we go to 8 when we hit the 41, but we didn't increase when we hit this one? And it has to do with transitions here. So you'll see if you look at adjacent values, the 41 differed from what came before it. It was a transition from the value before it. And that's why we increased our counter to 8. When we were here, we would see that there was no transition. What came before the 40 was a 40, and that's why we didn't increment our count here. Similarly, when we were here, we didn't increment because this matched what came before. Now, we had incremented when we saw the 40 because that was different than the 35 that came before. So the idea here is that in the if, what we'd like to say is if the list I that we're looking at is a transition, is somehow different from what came before, if it's not equal to the one that came before, well, the one that came before would be list I minus 1. That's the one that comes before it. So if the ith element of the array is different from the one that comes right before it, that's when we increment our counter. So that's the basic idea, and actually that's a pretty good idea. We don't have it quite right. We've got some things we've got to fix, but this isn't a bad starting point. So let's bring up our code here and go ahead and run it and see what happens. When we do run it, what we get is our testing code shows us what that array looks like. It says it has a length of 14. But then we get an array index out of bounds exception. This is a very common error when working with arrays. So we need to understand what's going on here. And there's some useful information that we're getting here. It's telling us that the index we used was -1. So that's worth noting. The other thing that it's telling us is that it was in line 31 of our program right here. This is a backtrace of how we got there. We were in line 6 in main, which called test, and we were in line 24 of test, which called num_unique, and we were in line 31. So this is a good time to switch on line numbers so that we can see these exact line numbers. 31, line 31, is that if that we introduced. So why are we getting an array index out of bounds? Well, I starts at 0, and the very first time through this loop then we ask about list 0 versus list 0 minus 1. 0 minus 1, that's where the -1 is coming from. So it's the very first time through this loop that we're generating this error. And if you think about it, it's because, well, if we're looking at a value like 41, we'd want to compare it against what came before, 40 compared against what came before, all of these things, even down to the 7, we'd want to compare it against what came before, but not in the case of the 5 itself, because there's nothing that comes before the 5. So we want to treat the first value of the array differently. If we're going to be comparing list I against list I minus 1, then we shouldn't let I be 0. So this is a case where we have a slight variation. We don't want to start at an index of 0. We could start at an index of 1 and treat the first value differently. We can go ahead and compile this version, and let's try running it and see what kind of output we get. And what it tells us is that there were 7 unique values here, 11 here, 2 here, 4 there. Remember those numbers for a second. 7, 11, 2, 4. 7, 11, 2, 4. So what we're getting is numbers that are off by 1, exactly 1 in every case, because we got 7 here, 11 here, 2 here, and 4 here. Well, and that's not surprising. It's because we're not taking into account that very first number in the list. We're starting at index 1 instead of starting at index 0, and our counter started at 0, so we haven't done anything in here to account for the fact that there's a number at the very beginning of the list. So instead of starting our counter at 0, we could start our counter at 1 so that we could by hand count the I0 case, that we know there's something sitting there at index 0, we set our count at 1, and then we start our loop at index 1. We go from there. So we basically hand set the count to be 1 to deal with this value here, this value here, this value here, and so forth, and the for loop looks at everything else that's in the list. So if we go ahead and compile this version and run it, what we'll see is that we get now results of 8, 12, 3, 5, 8, 12, 3, 5. That's all very good. And let's double check our other values here. 1, 1, 1, and our answers were 1, 1, 0. Well, we have a slight glitch right here, and you can see that in the case of the empty array, we're reporting that there was 1 unique number in the empty array. That's clearly a wrong answer. And unless you're told explicitly that you don't have to worry about that case, it's something that you do have to think about. So We were here assuming that there is a value in index 0. And there may not be such a value. So this is a case where we have a special case. If the length of this list is 0, then what we would do is to return 0 as our answer, and otherwise we could assume that we have at least one value in this list that we could count, and then use our for loop to count the others. So we can go ahead and compile this version and run this version of the code. And if we take a look at these answers, we're still getting the 8, 12, 3, 5 as answers that we got before, but now we're getting the answers 1, 1, 0. So now we're getting the right answer in each of our different test cases, and this turns out to be our solution to the problem.